All right, today we are going to work on multiplying binomials. This is one of my favorite lessons. You get to meet one of my favorite men in the whole world. Okay, so today we're going to look at a little challenge. I hope I gave this to you in class, but just in case I forget. What do you think the quantity x plus 5 times the quantity x plus 2 simplifies to? I want you to write on it your answer on a little small sheet of paper and save it to turn it in. Do not move on with this lesson until you have a guess for this, because it's really important that you have a guess and you're just making, a prediction about this problem. Okay. Most of you probably said something like x squared plus 10, or maybe 2x plus 7, or who knows what you said. But we're going to see if you're right. The first thing I want to do is plug in some numbers and just think about what this really means. Okay, so I want you to know that you can use an area model or the distributive property to multiply two binomials. So in that problem before, when we were doing x plus 5 times x plus 2, one way I like you to think about it is that you are multiplying. Pretend these are dimensions of a side. So we have x plus 5 here, and we have x plus 2. Okay, these are dimensions. There's a little rectangle there. X plus 5 is one side, x plus 2 is the other. If I was going to find the area of this, I'm going to just draw a couple lines here, just so I can separate that out into parts that I know how to multiply. So the top I have x, then 2, then x, then positive 5. So to get the area of that top left rectangle, I would do x times x, and that would be x squared. To do the area of the top right, I would do x times 2, which is 2x. To do the area of the bottom left, I would do 5 times x, which is 5x. And then if I did 5 times 2, I would get 10. And you probably know that when you're finding the area of a complicated region and you find the area of all the smaller parts, that to find the area of the entire thing, you add up all the small regions. So we're going to add all our like terms that we can at 2x and 5x. And we have an answer of x squared plus 7x plus 10. So if you actually got that without me giving you a hint, that's amazing. So what I'm going to look at here is a little bit more complicated problems. And we'll work with an area model first, which is what I just used, the rectangles. And then I'll also show you how to use distributive property to solve it. So we're going to simplify the quantity 2y minus 3 times the quantity y plus 2. If you want to make it an area model, you need to be careful. So it's like 2y minus 3 is the same thing as 2y plus negative 3. So I definitely like that, write that negative 3 altogether. And then y plus 2. Okay, I'm going to draw my line down to separate the regions into places, things that I can easily multiply. So I know 2y times y is 2y squared. 2y times 2 is 4y. Negative 3 times y is negative 3y. Negative 3 times 2 is negative 6. Okay, again, I want to combine all my like terms. Again, they show up right here. That's 1y. So I've got 2y squared, which is plus y, minus 6. Should be the way to simplify that expression from before. Okay, so I think with the next problem, I'm going to show you how to use distributive property if you don't like drawing the rectangle diagrams. So if I ask you here to simplify the quantity 3a minus 1 times the quantity 2a minus 4, what I'm really doing is multiplying the 3a by the 2a and the 3a by the minus 4. Okay, and then I'm going to multiply the negative 1 by the 2a and the negative 1 by the minus 4. Okay, I don't know if you can see it, but this is my favorite little man, this little baby. I call him George. Okay, see his red smile, and then he's got some two wispy things of hair and his beautiful ears. You might not be able to visualize it at home, but I promise he's so cute. Okay, so we're going to actually go ahead and solve this problem. So when I did 3a times 2a, I got 6a squared. When I did 3a times a minus 4, I get negative 12a. When I do negative 1 times negative 4, or I guess I'll do negative 1 times 2a first, I get negative 2a. And negative 1 times a negative 4, I get positive 4. Okay, and again, I'm going to add up my like terms. I get a negative 12a and a negative 2a. So I have 6a squared minus 14a plus 4. Okay, you could have definitely done the same exact thing by using a rectangle diagram. You have to remember it's 3a plus negative 1 though, then 2a plus negative 4. Multiply each section, you're going to get 6a squared, negative 12a, negative 2a, and positive 4. And then we add them all together, you're going to see I get the exact same thing, 6a squared minus 14a plus 4. Okay, so I'll let you use the method of your preference. Some teachers do not like this mnemonic device, but a lot of teachers just only refer to multiplying binomials by this. So I'm going to teach it to you. I'm not going to stress it. It's the same thing as using the distributive property when you have two binomials, but a lot of people call it FOIL. So I'm going to give you an example, again, a simple one, like x plus 2 times x plus 6. Okay? So to multiply two binomials, you can use this mnemonic device called FOIL, which says I'm going to take my first terms, which are x, and multiply them. So there we go, x times x is x squared. I'm going to take my outer terms, which is going to be the x and the 6, and multiply them. So I've got 6x. I'm going to take my inner terms, which is going to be this 2 and the x, and multiply them. 2x. And then L, I'm going to take my last terms, this 2 and this 6, and multiply them. Okay, so again, you can see I'm going to add my like terms, x squared plus 8x plus 12. I've just used the distributive property. Sometimes people call it FOIL. So if someone says, hey, I want you to FOIL those two binomials, that's what they mean. Okay, multiply them out. And there you go. Okay, try this one without me. Try to use FOIL or a rectangle diagram or just the normal distributive property. Okay, they all do the same thing. And see if you got this answer right without me. Okay, and then check. All right, so I'm going to multiply 4x by 3x first. I get 12x squared. And I'm going to do 4x times a minus 6. That's negative 24x. 2 times 3x, that gives me positive 6x. 2 times negative 6, that gives me negative 12. I need to combine my like terms. I'll be careful, that's a negative 24 plus 6, so got 12x squared minus 18x minus 12. That should be my simplified answer, and hopefully you got it. All right, let's look at one final problem. This problem, you're going to find the area of the shaded region and then simplify it. So I want you to think about if I just gave you something with numbers. I said, here's a 5 by 5 square, and inside it, we have a 2 by 3 rectangle, and this is all shaded. Okay, think about a strategy that you might be able to do. Go ahead and try to find the area of that for me. Okay, so I'm hoping you found the area of the entire square by doing 5 times 5 is 25. I'm hoping you find the area of the little rectangle, 3 times 2 is 6. And because you want everything that's in that big square but not in the little rectangle, we would subtract 25 minus 6. You should get an area of 19 square units. Okay? I want to use that same process to solve this problem. So what I'm going to do is find the area of the outer rectangle first. So I'm going to do 3x plus 2 times 2x minus 1. Then I'm going to find the area of the inner rectangle, so x times x plus 3. And then after I got those two answers, I'm going to go ahead and subtract them. All right, so it looks like we need to use distributive property or rectangle diagram or FOIL or something in this case. So I'm going to do 3x times 2x is 6x squared. 3x times a negative 1 is negative 3x. 2 times 2x is plus 4x. And 2 times a minus 1 is a negative 2. So I'm going to get my like terms, add them up. Got 6x squared plus x minus 2. Okay, and over here on the right side, x times x plus 3, I can just use straight normal distributive property. So that's x squared plus 3x. Okay, so I'm going to have 6x squared plus x minus 2, that whole thing, minus x squared plus 3x. So again, I like to distribute my negative sign because it makes it easier for me. So I'm doing 6x squared plus x minus 2 minus x squared minus 3x. I'm going to get all my like terms combined. I've got a 6x squared here and a minus x squared, so that's a 5x squared. Got a plus x and a minus 3x, so that's a negative 2x, and then this little negative 2 stands alone. My area of my shaded region should be 5x squared minus 2x minus 2. I'll say that's square units or units squared. Okay. So now you should know a little bit more about multiplying binomials than you knew in the past. It's a great topic. We're going to practice it over and over.